Hello everyone, welcome to my channel. Please like, comment and subscribe for more civil engineering tutorial. Today we will be learning how to calculate total energy and the vertical deflection of the truss system. Now consider this truss system. From the following truss system, determine the total energy of the system and the vertical deflection at point A. The total energy for truss system is obtained by taking the summation of normal force due to applied load times normal force due to applied load times length of the member over 2 EA. And the deflection at a certain point for truss system is obtained by taking the normal force due to applied load times normal force due to unit load times length over AE. Now, in order to obtain these normal forces, the first procedure is to draw the free body diagram of the truss system. The free body diagram. This system, this cantilever support, it have 4 supports: horizontal reaction and vertical reaction. This is vertical reaction for point C, LC, and HC. Horizontal reaction and LD, vertical reaction at point D and the horizontal reaction at point D. Now, in order to obtain this support reaction, we consider the equilibrium of vertical reactions. Consider equilibrium for horizontal reaction is equal to 0. Right positive and left side negative. Now, horizontal reaction HC, crocodile, right side plus HD is equal to 0. Now, consider also summation of moment for either at point C or point D, so as to obtain the reactions. Now, let's consider for summation of moment at point D is equal to 0. Clockwise positive, anti-clockwise direction negative. Now, for this point, HC it rotates in anti-clockwise direction towards point D, so it will be negative 10 HC, 20 kilonewton. It rotates clockwise direction towards point D, so it will be 5 times 20 plus even this 10 kilonewton, it rotates clockwise direction towards point D, so it will be 10 times its perpendicular distance is 10, so it will be 10 is equal to 0. Now 10 HC is equal to 200 kilonewton. Now HC it will be equal to 20 kilonewton. Now in order to obtain HD it will be equal to negative HC. Now HD it will be equal to negative 20 kilonewton. Now also consider summation of vertical reactions. So to obtain RC and RD, positive upward and downward negative. So for this system, upward we're having RC plus RD minus 20 minus 10 is equal to 0. RC plus RD will be equal to 30. So in order to obtain this RC and RD, we may cut a section for this truss system. Let's say cut section at this members member D, C, and D, AE. This is E. AE. After cutting the section, we may consider summation of moment at this point. This is summation of moment at point E to the light side of this section, this side. It will be equal to 0. Clockwise direction positive, anti-clockwise direction negative. Now HC, it rotates in anti-clockwise direction towards point E, so it will be, its perpendicular distance is 5, so it will be negative 5 HC. This 10 kilonewton rotates clockwise direction towards point E, so it will be plus 10 times 5, perpendicular distance 5 is equal to 0. Okay, plus RC. Plus RC's perpendicular distance. RC is it rotates positive clockwise direction towards point E. So it will be 5 RC is equal to 0. Now 5 RC it will be equal to 50 minus negative 50 plus 5 times HC. HC is 20 kilonewton, so RC will be equal to 10 kilonewton. 10 kilonewton. Now we have obtained all of the support reaction of this truss system. So in order to obtain the normal forces of the truss of each members, we may obtain by using joint method or section method. Now, for this case, we shall deal with joint method. Now, by using joint method, we enable us to obtain the normal forces for each members. Now, consider joint D, joint D, joint D, joint D, joint D. Joint D, it will be in this way. This is X, this is DE, DC. Here we have HD. Since HD we have obtained negative, so it will be in this direction. Negative 10 kilonewton, 20 kilonewton, LD 20 kilonewton. Okay, in order to obtain is the angle of this of A, that is the angle of this one or this one. Consider this one. So angle, we consider tan of angles is equal to opposite sides. When we prolong for this case, the distance of this region is 5. 5 adjacent also is 5. This one 5. So it will be tan inverse of tan inverse of 1. So the angle will be 45 degrees. So here will be 45 degrees. 45 degrees. Okay. Now consider summation of horizontal forces so as to obtain normal forces for DC, DE. Summation of horizontal forces, right side positive, negative. Negative 20 plus DE cos of 55 degrees equal to 0. So DE it will be 20 over cos of negative 5 dE, it will be equal to 20 divided by cos of 45. It will be 28 kilonewton. Also, summation of vertical force is equal to 0. Positive, negative. Here we're having 20 positive minus dC minus dE sine of 55 is equal to 0. dC, it will be equal to times sine of 45 minus 20, it will be 20 minus 20. So dC, it will be equal to 0 kilonewton. Our target is to find now. So, but let's fill these members for each member, DC, DE, BC, BA, AE. Now we have obtained for member DE. For member DE, normal force of applied load we have obtained 28.28. DC, we have obtained 0 kilonewton. Okay, let's proceed. Let's consider joint. Now for joint C. For joint C, it will be in this way. Joint C, it will be, this is BC, this is CE, this is DC. Here RC was 10 kilonewton. HC was 20 kilonewton. The angle of this one is 45 degrees. Now, consider summation in order to obtain normal force for CE and BC. Now, consider summation of vertical force is equal to 0. Positive, negative. So it will be DC plus 10 plus CE cos of sine of 45. Sine of 45 is equal to 0. Therefore, DC we have obtained is equal to 0. DC is equal to 0. So CE, it will be equal to negative 10 over sine of 45. CE, it will be equal to negative 10 divided by sine of 45. It will be equal to negative 14/14 kilonewton. Also, summation of horizontal force is equal to 0. Positive, negative. 20 kilonewton plus BC plus CE cos of 45 degree is equal to 0. So BC, it will be equal to negative 20 minus negative 15.14 cos of 45. Now BC, it will be equal to times cos of 45. It will be equal to negative 10 kilonewton. BC. Now let's feel this is all a normal force due to applied load. So let's feel BCE. CE we have obtained negative 15.14 kilonewton. BC is equal to negative 10 kilonewton. Negative 10 kilonewton. Also, let's consider joint B. Joint B. Joint B is this one. It will be in this way. Joint B. This is BE, BA, BC. Now, summation of vertical force is equal to 0. Positive, downward, negative. So, it will be vertical reaction you have only BC. So, BC will be equal to 0 kilonewton. BE, this is BE. BE, it will be equal to 0 kilonewton. Now, summation of horizontal force is equal to 0. Positive, negative. Negative BC plus BA is equal to 0. So, BC, it will be equal to BA, which is negative 10 kilonewton. Also, BE, we have obtained 0 kilonewton, and BA is equal to negative 10 kilonewton. These are normal forces due to applied load. Also, consider joint A. Joint A. Joint A is this one. So as to obtain member AE. To obtain member AE. So joint A, it will be in this way. Joint A, it will be in this way. This is BC, BA. This is AE. Here we having 10 kilonewton. Now the angle this one is 45 degree. Since opposite is 5, adjacent is 5, tan inverse of 1 is equal to 45 degree. 45 degree. Now let's proceed. To obtain AE, we may consider summation of horizontal forces is equal to 0 or summation of vertical forces is equal to 0. Let's consider summation of vertical force is equal to 0. Positive, negative. So now having AE positive this way, AE sine of 45 degree minus 10 kilonewton is equal to 0. Now AE, it will be equal to 10 over sine of 45 degree. Now AE, it will be equal to 10 divided by sine of 45, it will be equal to 14.14 kilonewton. This is kilonewton. 14.14 kilonewton. Now let's fill AE. It will be 14.14 kilonewton. Now, all of these are normal forces due to applied load. So, in order to obtain normal force due to unit load, now we remove all applied load and applied unit load for point A, so as to obtain vertical reaction at point A. So, let's say remove all applied load. Remove all applied loads and introduce unit load at point A. So to obtain unit unit load for this member, normal force due to unit load for all of these members. So it will be, after removing all applied load, the system it will be in this way. It will be in this way. This is point A. Here we introduce unit load for point A, 1 kilonewton. This is point A, point B, point C to LC, HC. This is point C, point D, HD, vertical reaction at D, LC, LD. So this is point D, point E. Here we have removed all applied load and we have introduced this unit load for point A. So this will enable us to obtain normal forces due to unit load. Now, in order to obtain this normal forces, first of all is to find this support reaction. So, in order to obtain this support reaction, we may consider summation of horizontal force. Horizontal force is equal to 0. Positive, negative. Here we have HC, positive plus HD is equal to 0. This is, we may call question number 1. Also, let's say take summation. In order to obtain this HC and HD, we may take summation for moment at either at this point, at a point where there lies at least 2 members, at either at this point or at this point. So let's say take summation of moment at point D is equal to 0. Clockwise direction positive and clockwise direction negative. Okay, so now in order to obtain moment around this point, HC, its perpendicular distance is 5 meter, 5 meter. Here was 5 meter, 5 meter. So in order to obtain the moment for this case, HC, it moves, it rotates towards this point in anti-clockwise direction, so it will be negative 10 HC. This unit load, it moves clockwise direction, so it will be 1 times perpendicular distance 10. So 1 times 10 is equal to 0. So HC, it will be equal to 1 kilonewton. So HD, it will be negative HC. Now HD, it will be negative 1 kilonewton. Also, to obtain LC, it is summation of vertical force is equal to 0. Vertical forces we have in LC which is upward plus LD minus downward unit load which is 1 is equal to 0. So it will be LC plus LD is equal to 1. Let's call question number 2. This is question number 1. So to obtain LC and LD, we may cut a section to these members. After cutting a section to obtain LC and LD, we may take summation for moment at this point is equal to 0 for light side of this section. So let's say summation of moment at point E, light side of this section is equal to 0. Clockwise direction positive and clockwise negative. So HC, it rotates towards point E in anti-clockwise direction, so it will be negative HC. Negative, its perpendicular distance 5, so it will be 5 negative HC. LC, it rotates towards point E in clockwise direction, so it will be 5 LC positive. and unit load it rotates towards point E in clockwise direction, so it will be 1 times its perpendicular distance 5, so it will be equal to 0. RC 5 RC, it will be equal to HC, we will obtain 1, so it will be when 5, it will be 5 HC, which is 1 minus 1 times 5, so RC it will be equal to 0 kilonewton. It will be equal to 0 kilonewton. It will be equal to 0 kilonewton. Also, to obtain RD, now we have obtained RC. So to obtain RD, we come for this question number 2. So RD, since RC we have obtained is equal to 0, RD it will be equal to 1 kilonewton. Now we have all obtained these vertical support reactions. So to obtain normal forces due to unit load for all members will be obtained by using joint method. Now let's consider joint D. This is joint D. After that we consider joint C, B, A, so as to obtain normal force unit load for all members. Now consider joint D. Joint D it will be in this way. Here this is X axis. This is DC. Here HD was negative 1. So since it is negative, was in this its direction is this way. So since it's negative, its direction will be it will be in the opposite direction. So it will be 1 kilonewton. RD, we have obtained RD 1 kilonewton. So this is 1 kilonewton. Here 45 degree. This is DE. So to obtain DC and DE, we take summation of horizontal force is equal to 0. Positive this way, negative. Okay, this is negative 1 plus DE cos of 45 is equal to 0. DE it will be 1 over cos of 45. So DE it will be equal to 1 divided by cos of 45. It will be equal to 1.414 kilonewton. So to obtain DC, take summation of vertical force is equal to 0. Upward positive, downward negative. Positive 1 minus DC minus DE sine of 45 is equal to 0. So DC it will be equal to this DE with 1.41 times sine of 45. This is 1. So DC it will be 1 minus 1, which is equal to 0. DC it will be equal to 0 kilonewton. Now let's fill for this to our table. DE we have obtained 1.414. DC 0 kilonewton. After that, let's consider joint. This joint C. Joint C, it will be in this way. This is DC. This is BC. RC was 0 kilonewton, so RC was 0 kilonewton. HC was 1. Now this is 45 degree. 45 degree. This is CE. CE. Now, in order to obtain CE and BC, DC we will obtain which was DC chose 0 kilonewton. So, in order to obtain CE and BC, we may take summation of vertical force is equal to 0. Summation of vertical force is equal to 0. Summation of vertical force DC is DC plus CE sine of 45 is equal to 0. DC is equal to 0. So since DC is equal to 0, CE it will be equal to 0 minus sine of 45 degrees. So CE is equal to 0 kilonewton. To obtain BC, take summation of horizontal force is equal to 0. Positive this way and this way negative. So 1 plus BC plus CE. CE is equal to 0, so it will be equal to 0. BC it will be equal to negative 1 kilonewton. Now let's record it to our table. CE 0 kilonewton, BC negative 1 kilonewton. Negative 1 kilonewton. Negative 1 kilonewton. Now let's proceed for joint B. So to obtain for joint B. Now consider joint B. Joint B. Joint B, it will be in this way. This is BE. This is BA. This is BC. So now in order to obtain BE and BA, BC we have obtained. So in order to obtain BE and BA, now let's take summation of vertical force is equal to 0. Vertical force is only BE, so BE it will be equal to 0 kilonewton. Also take summation of horizontal force is equal to 0. Positive this way, negative. So negative BC plus BA is equal to 0. BC it will be equal to BA, which is equal to BC was negative 1 kilonewton. So BA it will be negative 1 kilonewton. Now let's record it to our table. BE is 0 kilonewton, BA negative 1. So remain member AE. To obtain member AE, consider joint A. Joint A. Joint A it will be in this way. This is 1 kilonewton, this is joint A. Joint A. BA AE. Now the angle this one is 45 degrees since tan of angle is equal to opposite 5 meter of adjacent, which is 5 meters. So the angle it will be tan inverse of 45 over 45, which is equal to the angle will be tan inverse of 5 meter over 5 meters, so which is equal to 45 degree. This is 45 degree. So now to obtain AE, we may use either summation, we may consider horizontal forces or vertical forces. Now let's consider summation of a vertical force is equal to 0. Positive, negative. So here negative 1 downward plus AE sine of 45 degrees is equal to 0. So AE it will be equal to 1 over sine of 45 degree. So AE it will be equal to 1 divided by 45 it will be equal to 1.414 kilonewton. Now let's consider to this thing. So it will be 1.414 kilonewton. Now let's find summation of all members. Okay, to obtain the lengths of each members. This is the length for member AE. To obtain the length for member AE, to obtain the member of DE, so it will be, we may proceed in this way. So to obtain member DE, it will be equal to DE by using Pythagoras theorem. So to obtain DE, when you proceed in this way, it will be this way. DE is this one. So it will be, to obtain DE, it will be 5 square plus 5 square. 5 square plus 5 square under root. DE, it will be 5 square plus 5 square under root answer. It will be 7.07. DC is this one. The distance of DC is 10 meter. To obtain CE is this one. CE similar, it will be obtained by using Pythagoras theorem. 5 meter. So 5 square plus 5 square under root, it will be 7.07 meter. BC is this one. Its distance 5 meter. 5 meter. BE is this one. Its distance is 5 meter. So we'll record 5 meter. To obtain BA is also 5 meter from this one to this one. So it will be 5 meter. To obtain AE, similarly by using Pythagoras theorem, 5 square plus 5 square under root of answer, it will be 7.07. Okay. To obtain normal force due to applied load times normal force due to applied times length, so we multiply this one times this one times this one. We will obtain normal force due to applied load is a product of normal force due to applied load times length. So it will be 28.28 square times 7.07. It will be equal to 5654.29. This 0 times 10, it will be equal to 0. Okay, for this case, 14.14 square times 7.07, it will be 1413.57. Now this one, 10 square times 5, it will be equal to 500. 0 times 0 times 5, it will be 0. Here it will be also 500. For this one, it will be similar to this one, which is 1413. Now let's find the summation of all. It will be 5654.29 plus 1413 plus 1413.5. It will be equal to 9481.43. Now let's find the product of normal force due to applied load times normal force due to unit load times length. So it will be 28.28 times 1.414 times 7.07. It will be equal to 282.71. For this one, 0 times 0, it will be equal to 0. It it will be equal to 0. Okay. Also for this case it will be equal to 0. Since 0 times this one times this one times this one, it will be equal to 0. Now 1 negative 1 times this one times this one, it will be 50. 0 times 0 here, 0 also 50. Now let's take summation of this one. Also 1.414 times 4 times rings 7.07. It will be equal to 141.56 plus 100 plus 282.71. It will be equal to 524.07. This is the summation of normal force, the product of normal force times normal force equivalent load times length. Okay. Now let's fill this is, let's say this is for vertical for support reaction. This is RC, HC, RD, HD. RC was 10 kilonewton. RD was 20 kilonewton. HC was 20 kilonewton. Negative 20 kilonewton. RC was, no, this is for length. This is for length. Length is 0. So here was 10 kilonewton, 20 kilonewton, 20 kilonewton, negative 20 kilonewton. For normal force here, RC was 0. HC was 1 kilonewton, RD was 1 kilonewton, HD was negative 1 kilonewton. Now to obtain our question, we were required to find the total energy and the vertical deflection at a total energy is obtained by taking summation of normal force to applied load times normal force to applied load times rings over 2 AE, where AE is constant. So total energy, it will be equal to summation of normal force, this one, it will be 81.43 over 2 AE. So it will be equal to 9481.43 divided by 2. It will be equal to 4740 kilojoule over AE. Now, total energy of the truss system will be equal to 4740.5 AE joule. Deflection at A, it will be equal to summation of normal force due to applied load times normal force due to unit load over times L over AE. The summation of normal force to applied load times normal force due to unit load times L is this one. So we write here deflection at A, it will be equal to 524.07 AE. This is meter. Thank you for watching this video. Please like and subscribe for more civil engineering tutorial.